Next meeting is on Tuesday?
Yes. Okay, so let's take a look at the segment addition postulate. These are guided notes. You'll have these a couple of times. They're really easy. Just follow along, fill in the blanks, and when you're done, all you have to do is show me the paper or take a picture and upload it to Google Classroom for credit. All right, let's start with just a simple definition of what the segment addition postulate is. It sounds way more complicated than it actually is. Basically, you're just saying that given 2 points, that's your first blank, A and C, a third point lies on the, if I can get my pen over there, segment AC, and, whoops, my bad, and the distance between the points satisfies the equation AB plus BC equals AC. Just a real simple definition. It makes more sense if you see a picture though. Say we have a line segment and it's got 3 points on it, A, B, and C. A is an endpoint, so let me go ahead and write that in. A is an endpoint. C is also an endpoint. And B is between. I think we all know what that word means, but the word is between A and C. It's fairly easy to see that AB plus BC would equal AC. Like if you take this part right here, which is AB, and you take this part right here, which is BC, it would equal the whole thing all together. So AB plus BC equals AC. And we'll just use that simple fact to solve out a few simple geometry problems. So sometimes the segments are labeled with an actual distance. So your blank here is the word, if I can get it to work, distance. What is the length of AC? Well, think about it. You've got your equation, AB plus BC equals AC. So you got your first part, second part equals the whole thing all together. So let's just go ahead and say AB is 5, BC is 7. So really all you're doing is just adding 5 plus 7. So AC equals 12. Really simple stuff. And you'll get a couple easy questions on the IXL that you'll do later. Sometimes only a segment in the middle might be missing, but you still know the total length. So your blank right here is total length. So let's look at this. You've got AB, which is unknown, question mark, or if you like to think of it as X, you can do that. BC is 7, and then the whole thing altogether is 40. So we know that AB is unknown, BC is 7, and the whole thing altogether, total, is 40. So just by using some basic algebra, subtract 7 on both sides, we know that X equals, I think, if I did my math right, 33. So X, or you could say that AB was the missing quantity, and AB equals 33. I hope that makes sense. I hope that's not too confusing. It's pretty easy stuff. So if only math always stayed that easy. Sometimes we want to get a little bit crazy with it. So look at this problem right here. I added some algebra into it. So say you have AB is X, BC is 7X, and the total distance altogether is 40. So we still could set up an equation. So we're going to say that AB is X. We're going to say that BC is 7X. And our total value altogether is going to be 40. Okay, we just need to solve our resulting equation. So basically, usually what you'll need to do at this point is combine like terms. Star. So we're going to go ahead and do 8x for x plus 7x. So we're going to go ahead and do 8x equals 40. Then we're going to go ahead and divide by 8 on both sides. And so we would get that x equals 5. That might be what the question is asking, but more likely they're probably asking what is AB and what is BC. So AB is x, which is 5, and then BC was 7 times x. X was 5, so that would be 35. And if you just want to do a quick check, if you add those two together, it equals 40, which totally works out with, that got weird, but with the total that we were supposed to get. So everything works just right. Okay, let's do one more. This would be, I think, the next level of challenge, because all they gave you are points. So you got points A, B, and C. B is between A and C. Solve for x. I wrote the diagram, but I need to label my own diagram. So the whole thing all together, A to C, is going to be 3x plus 3. AB is going to be -1 plus 2x. And BC equals 11. So now I need to go over here and set up my equation. So I know that AB plus BC has to equal total AC. So I'm going to do this part right here, which is just AB. So I'm going to go over here and do -1 plus 2x. That's just this part. And I also need to have my BC, which is 11, so I'm going to add that in as well. And then that has to equal the total, and the total was 3x plus 3. So I need to make sure to put my 3x plus 3 right there. Okay, like I said before, combine like terms is my best friend. I know that I have a -1 and an 11 right here to combine. So that's going to become 10. My 2x has nothing to combine with, so I just pull it down. And it's going to be equal to 3x plus 3. That didn't change. I'm going to go ahead and subtract 2x on both sides. If you don't know, the easiest way to solve an equation like this is to subtract the smallest variable on both sides. That's the easiest way to do it. So cancel that, leaving me with 10 equals, what's 3x minus 2x? That's x. And you can pull down the 3. And then it's a simple one-step equation to basically subtract 3 on both sides. And x would equal 7. That actually means that AB, if they asked you for AB, would be -1 plus 2 times 7, because 7 was x. So AB equals -1 plus 14, which equals 13. BC was already known, and the total, AC, was equal to 3x plus 3, but we know that x is 7. So we're going to do 3 times 7 plus 3. So that would be 21 plus 3. That would be 24. And that seems a little bit right. If you hung in with me this far, 13 plus 11 equals 24. So if I added this plus this, then 11 plus 13 equals 24, which is the total. It's always a good idea to check your work. Okay, on the bottom, go ahead and do as many of the independent practice problems as possible, and be sure to show your paper to me or take a picture of the front and back and upload it when you are done for credit on the assignment. Thanks.